Graph g of x equals x squared minus 4. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Then make a table of values. Substituting negative 4 for x in the function g gives g of x equals 12. Similarly, when x equals negative 2, g of x equals 0. When x equals 0, g of x equals negative 4. When x equals 2, g of x equals 0. And when x equals 4, g of x equals 12. Next, plot the ordered pairs negative 4, 12, negative 2, 0, 0, negative 4, 2, 0, and 4, 12. Then draw a smooth curve through the points. Both graphs open up and have the same axis of symmetry, x equals 0. The vertex of the graph of g, 0, negative 4, is below the vertex of the graph of f, 0, 0, because the graph of g is a vertical translation 4 units down of the graph of f. Graph g of x equals 2x squared plus 4. Compare the graph to the graph of f of x equals x squared. Begin with the graph of f of x equals x squared. Then make a table of values. Substituting negative 2 for x in the function g gives g of x equals 12. Similarly, when x equals negative 1, g of x equals 6. When x equals 0, g of x equals 4. When x equals 1, g of x equals 6. And when x equals 2, g of x equals 12. Next, plot the ordered pairs negative 2, 12, negative 1, 6, 0, 4, 1, 6, and 2, 12. Then draw a smooth curve through the points. Both graphs open up and have the same axis of symmetry, x equals 0. The graph of g is narrower, and its vertex, 0, 4, is above the vertex of the graph of f, 0, 0. So the graph of g is a vertical stretch by a factor of 2 and a vertical translation 4 units up of the graph of f. Graph of Let f of x equal negative 75/100 x squared plus 1, and g of x equal f of x minus 3. Part A. Describe the transformation from the graph of f to the graph of g. Then graph f and g in the same coordinate plane. Notice that the function g is of the form y equals f of x plus k, where k equals negative 3. So the graph of g is a vertical translation 3 units down of the graph of f. To graph each function, first you want to make a table of values. To find the values of f of x, evaluate the expression negative 75/100 x squared plus 1 for different values of x. When x equals negative 4, f of x equals negative 11. When x equals negative 2, f of x equals negative 2. When x equals 0, f of x equals 1. When x equals 2, f of x equals negative 2. And when x equals 4, f of x equals negative 11. To find the values of g of x, evaluate the expression f of x minus 3 for different values of f of x. When f of x equals negative 11, g of x equals negative 14. When f of x equals negative 2, g of x equals negative 5. When f of x equals 1, g of x equals negative 2. When f of x equals negative 2, g of x equals negative 5. And when f of x equals negative 11, g of x equals negative 14. To graph the function f, plot the ordered pairs negative 4, negative 11, negative 2, negative 2, 0, 1, 2, negative 2, and 4, negative 11. Then draw a smooth curve through the points. To graph the function g, plot the ordered pairs negative 4, negative 14, negative 2, negative 5, 0, negative 2, 2, negative 5, and 4, negative 14. Then draw a smooth curve through the points. Part B. Write an equation that represents g in terms of x. First write the function g. G of x equals f of x minus 3. Next substitute negative 75/100 x squared plus 1 for f of x to get g of x equals negative 75/100 x squared plus 1 minus 3, which simplifies to g of x equals negative 75/100 x squared minus 2. So the equation g of x equals negative 75/100 x squared minus 2 represents g in terms of the function h of t equals negative 4 9/10 t squared plus s sub 0 represents the approximate height in meters of a falling object t seconds after it is dropped from an initial height s sub 0 in meters. A coin is dropped from an initial height of 44 1/10 meters. Part A. After how many seconds does the coin hit the ground? Because the coin is dropped from an initial height of 44 1/10 meters, the function h of t equals negative 4 9/10 t squared plus 44 1/10 represents the height of the coin t seconds after it is dropped. The coin hits the ground when h of t equals 0. Make a table of values. Substituting 0 for t in the function h gives h of t equals 44 1/10. Similarly, when t equals 1, h of t equals 39 2/10. When t equals 2, h of t equals 24 5/10. And when t equals 3, h of t equals 0. So to sketch the graph, plot the ordered pairs 0, 44 1/10, 1, 39 2/10, 2, 24 5/10, and 3, 0. Then draw a smooth curve through the points. Next find the positive 0 of the function. When t equals 3, h of t equals 0, so the 0 is 3. So the coin hits the ground 3 seconds after it is dropped. Part B. Suppose the initial height is m meters lower. How will this affect Part A? When the initial height is lowered by m meters, the graph of h is translated down m units, so the x-intercept will move left. So the coin will take less than 3 seconds to hit the ground.